Hi everybody, we're going to do some super relaxed evening game hacking today. And the game that I'm aiming at is Super Tux 2. Probably most of you have seen it already. It comes with Ubuntu. I don't know if it's pre-installed. I had to install it on my machine just with sudo apt install supertux, and then you get this fun little game. It's basically like Super Mario, but in the Linux way. So here's the game. I don't know if I can skip this storyline. Oh yeah, I can. And what we have to do is we just press escape to skip. Wait. Ah, okay. I get it now. I have never played it before. Basically, it's like Super Mario, and we have to collect coins and reach the end of the level. So we can walk around here, jump, and die. Yeah, great example. But what we want to do in scope of this video is not play this game. I want to have a ton of coins. So in the top right corner, you see that I currently have 104 coins, which is too little. I want to be super rich. And today I discovered a nice little utility, a nice little tool on GitHub that is called scanmem, which is a memory scanner for Linux. And it's basically the same thing as Cheat Engine for Windows, but for Linux. And scanmem is a debugging utility designed to isolate the address of an arbitrary variable in an executing process. So this game right here is an executing process right now. And of course, this coin count is a variable. I don't know if I can zoom in a bit to make it bigger for you. Window resizable, window resolution. I think it is how it is. So the coin count is a variable, obviously, such as every other thing in this game is a variable. For example, the coin counter down here, 3 out of 105 coins collected is a variable, 2 out of 14 enemies destroyed, and 0 out of 1. What is that called in English? That lucky thing. Shamrock? Cloverleaf. Who cares? Okay, but let's get to the point. We want to modify the coin counter. And to do that, we have to run supertux, obviously. And this is now in our Linux system a running process. And to inspect running processes, most of you probably know that we can use ps-aux. And then we can print the processes there. And as you can see, I have a couple of processes running. Tmux, which is my terminal multiplexer. And as you can see, there's this super cut-off process. This is probably the supertux process. I don't know why it doesn't wrap around the line here. Maybe if I do ps-aux and then I pipe that into less, that will wrap around. Yes. So as you can see, supertux 2 is a process, and it has the process ID 406. So the second column, PID, is the process ID. It's an identifier for the running process. So let's remember the number 406 and open the cloned repository scanmem. I have already cloned it before. If you want to clone it yourself, all you have to do is just copy that URL here, and then do a git clone and then paste that here. I've already done that. I've also already installed it by following this guide here on this GitHub page. All you have to do is call the autogen script and then call this command and then this one, the configure command, and then make and then sudo make install. That's it. I also had to install a couple of dependencies, but it was quite easy overall compared to other stuff, compared to other packages on Linux. And now we can call, oh, what did I do? Now we can call scanmem, and it opens and it tells us that we can enter help for a list of commands, or we can enter right away the PID of the process to search using the PID command. So that's what we're going to do first. PID 406, that is our process ID. And by the way, this is using the maps file located at processes 406 maps. And let's have a look at what that is. Processes 406. Well, let's have a look at processes first, at proc. This is a directory that contains all running processes currently. All currently running processes are here. And as you can see, all the process IDs that were listed when doing PS are also listed here. So this is a pseudo directory. Proc is a pseudo file system. It's not real files, it's a pseudo file system, which serves as a utility to inspect running processes and their memory layouts. And it provides an interface to kernel data structures, yeah? And the processes running in memory are obviously kernel data structures. Okay. I think that's it. We don't have to go into more detail now. What we can do though is we can have a look at the process that we're dealing with, process 406. And under that, there are a couple of, I don't know, are they text files or binaries? Let's have a look at the CPU set, for example. That's an empty file. What else is there? smaps. So that is just kernel level data that is shared with us here. And the thing that scanmem is accessing is the maps file located at processes 406 maps. And as you can see, this is the maps file. Let me just make it more readable for you by splitting up my window, and let's open it again. I don't know if that's really more readable, but it lists a start address, an end address, and then I think a name of the memory segment this is mapping to. I'm not sure exactly, but overall you can see here, right? Let me just copy that file. Let's copy that file temporarily so I can show you better. Maps copy here, and let's shift this down. So we have a list of memory segments here and an associated name or associated program. I'm not too sure about that, but one of those memory segments is the heap, and this is the memory range of the heap. And there are tons of other memory segments here that are being used by the process. So we also have def0 for some reason, I don't know why. And of course that process is also referencing libraries. For example, libdb, or what else is there? libudev, libssl, etc. So this is a nice way to know a lot of stuff, to get to know a lot of stuff about memory layouts of running processes. And scanmem is using that maps file to locate memory regions to scan. And now technically we could somehow, using GDB or some memory analyzing tool, inspect those memory regions that are listed under that maps file manually. And we can then scan for the variables we are interested in and see how they change. But that all of that is a ton of effort, and there's really no reason to do that manually. And scan memory is a utility that allows us to track a variable, and as it changes, we enter the changed values in scan memory, and by narrowing down with each iteration the number of found values in memory, we eventually arrive at our target variable in memory. So if we enter right now 104, the number 104, let's do that. Well, let's start with help. We want to match a number, and I think by default it matches numbers. We can also match strings. We can match values that have increased or decreased by some number. I think for matching a number, we don't have to type anything. We can just match 104. No. The process failed to attach to 406. So probably we have to open scanmem with sudo, such that we have access to the memory. Now the value is still 104, so let's type that. No, let's first define the PID again, which is 406. It's found the memory regions here, and now let's track the variable. And as you can see, we typed 104, and we have 105,060 matches of the value 104 in memory. So we can't just manually scan the memory for the value 104. That would be so exhausting. So how can we narrow it down? Some of those variables that are found here, they change over time. Some of those variables will be 105 now, some will be 1000 now, depending on what they track. So we can just type 104 again, and let's remember the number 105,000 matches before. Let's type 104 again, because the value is still 104 in memory. And we have only 104,000 matches. So some of those other variables that we have scanned before have already changed. Yeah. So let's continue playing the game to enforce a change of that variable ourselves. So let's try to do that. This is just an info box, I think. Okay, all of those are nothing. So that's a snowball. I don't think it gives me a new coin, but it gives me an additional life. That's a coin, that's a coin. Oh God. Let's set the value to 110. Let's go back to the scan memory and let's search for 110. And as you can see, we narrowed down from 104,000 matches 104,751 matches for everybody autistic here. That was, by the way, that was not a condescending joke. I know some people are sensitive. We just narrowed down from 104,751 to just 3 matches. That means, and that is also quite funny, that by coincidence, there are 3 variables that changed from 104 to 104 to 110. So they have the same values. All right, but I would expect this to be just one variable in memory. There would be no reason for 3 variables to track the same thing. So now it's 111, and let's type 111, and we have now 2 matches, so there's just 1 to eliminate. Let's get all of those coins, and let's exit or stop the game, pause the game, and now it's 115. So let's go back and type 115, and we still have 2 matches. That looks like there are indeed 2 variables tracking the same thing, although that would be very unlikely. Okay, let's type 118. We now have 118 coins. Still 2 matches. 119 now. Still 119. Huh? $121. Okay, it seems like there are really 2 variables tracking the same thing. And let's open the help again. And as you can see, there are now a couple of options that we have. And one of them is the list option. And we can use that to list the matches. And as you can see, we have 2 matches on, both are on the heap and both have the value 121. So maybe we should try setting both of those to the new value. And we can do that by setting. And that changes all known matches to the specified value. We can also type help set and see what options it has. We can also specify a match ID. And if it injects the value n into all the matches in match ID set, or if just n is specified, so the number we want to set to, then it will inject the value into all known matches. And the value n can be specified in C standard language, so we can have a leading 0x for hexadecimal, a leading O or 0, O, I think it's O, for octal, and everything else is assumed to be decimal. Okay, so let's try to set to update that value in memory. So let's return to the game. It's now our coin count is now 121. And let's go and set, let's say 777. And let's go back to the game, and we have 777 coins. How awesome is that? So let's see if we can resume playing the game. And indeed, we can still collect coins, and the coin counter increases. What happens if we now enter the updated value here, 783? 783. We still have 2 matches, so for some reason we have 2 variables tracking that coin count. Then let's set something ridiculously large to just celebrate our success. and see what happens. And as you can see, we now have 9,999 coins. And interestingly, that's quite interesting, I set a larger number than that in this command. I set 9,999,999. And oh, I accidentally just exit the game. But we just found that the value is capped to some degree. So let's set it again and see if it's, yeah, and the change is effective again. So that is basically how you can cheat in any game. You can update any value in memory like that. And just before we quit this video, there's a small story that I want to tell. This works even with stuff that's running in your browser. And like 15 years ago, when I was a young teenager in my early teenage years, I managed to set the score in some online games on a popular online game platform. And I basically cracked the high score for many games and entered myself as the best in the world by modifying the score there. There was no memory protection back then and no high score modification protection back then. And then I uploaded a YouTube video showing how to do that on that specific game platform. And then the owners of that game platform, they somehow found that video and then patched that way to hack games like that, and kicked me off the platform and deleted my account. Well, that's the story, but that's how you hack games locally, and it's quite fun. You can change any memory value, by the way, that you want. You can also change strings or bytes, anything. This is not restricted to games. You can change anything in memory, and it's quite useful to know. And yeah, let's not drag this out too long. If you enjoyed this video, then stick around and see you next time. Bye.